Welcome to Making Democracy Work, brought to you by the League of Women Voters of Honolulu. We bring you topics of community interest every month. This month, we're going to talk about the Sand Island Waste Treatment Plant, which is run by Synagro. I am Pearl Johnson with the League of Women Voters. We have with us today Lane Baroldi, who is the Legislative and say it again,
Regulatory Affairs Director.
All right. Thank you, Lane.
My pleasure.
Who is visiting us from Los Angeles. And also Michael Marrero, who is the plant manager at the Sand Island Waste Treatment Plant for Synagro.
Yes, I am.
Thank you very much for being here.
Our pleasure.
Now, let's talk about what Synagro does at Sand Island.
Great. Well, defer to you on that, plant manager.
So I've only been here a short time, and the in-vessel bioconversion facility, they take in the sludge from the wastewater treatment plant that they take from the city. And we take that, digest it, process that where we remove the biosolids out of the water, return the water back to the wastewater treatment plant, and we process the solids, the biosolids remaining, that we develop and produce this pellet through our dryer and send that off to be used in agriculture.
Mm-hmm. Yes, and Synagro does this all over the country, is that correct?
That's correct, Pearl. We have operations currently in 34 different states. Within the United States, we not only do pelletization, we do lots of different things with the biosolids. We'll do direct land application, we'll pelletize it, we'll compost the material. We'll incinerate it. We do numerous things with the biosolids, just depending on what the host jurisdiction wants us to do with the material.
Mm-hmm. All right. Now, I understand that Synagro's history in in Honolulu started in 2002, when we first decided that we needed to stop sending how many truckloads of sludge into the landfill every day.
Yeah, depending on the size of the trucks at that time and with the level of treatment, it could have been up to 40 trucks a day at the peak of the hauling to the landfill.
Yes, and so instead, what happens is that your plant processes it and produces dry pellets, which can be used as
It's a fertilizer.
fertilizer, land amendments.
Yes.
Yes, and it's very easy to handle,
It is.
unlike sludge.
It is.
Definitely. And what it's done is a tremendous job in just reducing the volume and the impact on just the roads. I mean, there's a lot of traffic here, and when you reduce the volume, you definitely take a lot of trucks off the road, which helps with congestion and all.
Yes. I was told that it was really difficult to not only transfer the sludge, but to get rid of it there. Yes.
At the landfill.
Right.
Yes.
Yeah. And so what is happening with the pellets that you produce?
Well, we have a local distributor that comes to take our pellets after we've produced it. We're generating about 30 tons a day, and they'll come in with their truckloads to about 2 trucks a day, depending on how hard we're processing that day. And they'll take it to their various local farms distributions that they have here on the island.
Yeah.
So it's farms that are using it?
At the moment, yes.
Yeah, and we're trying to diversify that also. We've worked with our processor, and he's using some in blending with soil just to make a soil product. So I'd say pushing 10% of the material right now is going into that market. We're also looking at marketing some of the pellets that don't quite meet specs, a very, very small percent, to use with its energy value. It has a biogenic carbon source that is like a low-grade coal. And so we're working right now with the city and county staff and also with H-Power to use that fraction that can't be used in different markets as a beneficial use market in producing power. The material has what they call a British thermal unit of greater than about 5,000 BTUs, which, and I think this product is better than most pellets. I think around the nation it's a little higher. I think it's pushing 7,000 BTUs, which makes it an ideal coal substitute to help at H-Power.
All right. Now, as a comparison, what is the BTU for coal?
It depends. I mean, there's low-grade coals in the western part of the states, and Wyoming area. I've seen 12 to 16,000. Some of the material Pennsylvania is higher than that, but it has comparable characteristics for use
Yes.
as an alternative fuel.
And so you would be marketing it to Hawaiian Electric?
H-Power.
Oh,
I think
I
that's part of
see.
Covanta. And I
I
think there's another
see.
company that I'm not that familiar with. I think there's an AES also.
I see.
Yeah.
Now, has there been any nutrient analysis of these pellets?
Yes, frequently. It's done on a very frequent basis. There's certain requirements by the federal government for constituents, not necessarily the nutrient constituents, but other constituents. But that test is done, I think, on a monthly basis, at least right now?
Well, we have a monthly requirement to do lab testing on the pellets that we produce for various minerals, fecal matter as well, to make sure it's still a Class A level pellet. But in terms of nutrients, it's a NPK scale of 420.
I see. So when you say Class A, what does that mean?
Well, it's pretty much void of any fecal matter, any kind of, what's the term I'm looking for?
You're looking for, what EPA has set standards for is the different classes of biosolids, and they've done a lot of testing throughout the years, and candidly, it's probably the most tested material out there. And what they've set standards are for different classes of biosolids. What you'll typically see coming out of a digester, just directly out of the digester at Sand Island, would be called a Class B biosolid because it's gone through what they call a process to significantly reduce pathogens, which means that this material is in the egg for an average of greater than 15 days at a temperature of greater than 95 degrees Fahrenheit, where you get, in effect, a kill-off of 99-fold of what went into the digester. And what EPA has declared is that is a very safe product used, even without pelletization, on ag land when you use it in conformance with additional setbacks, times, and different factors that is in the regulation to make sure that public health and safety is protected. With the dryer and having the process go through a very high temperature regime and drying it out to greater than 90% solids, what you do is go through a process to what they call further reduced pathogens, in effect to make it essentially pathogen-free. So you have a product that is completely safe that you can buy in a marketplace because it's gone through such rigorous physical, processing.
So you say it's pathogen-free.
I said essentially pathogen-free. There's a
all right.
very, it's not quote-unquote sterilized, but essentially for the purpose of EPA's risk assessment, they said there's no risk to this, marketing it as a product that you can buy in the store.
I see.
So,
All right, I think we need to back up
Sure.
for our audience because you said egg and, people don't really know.
Sure.
We need to go through the process, all
Absolutely.
right, from the toilet.
I'll be glad to do that. Before I came to Synagro in 2009, I worked for a wastewater agency in Orange County, California, called the Orange County Sanitation District, from about '87 through 2009. So I'm familiar with the process. So I'm going to make it very generic. But you said from the toilet through
Yes.
the system. So once it leaves your residence through the toilet, the wastewater, along with whatever solids are in it, go through what they call a collection system, which are the pipes that lace throughout the cities under the streets. And what happens is this material goes to the treatment plants. And what you'll typically find are treatment plants at a very low spot within the community because communities want to take advantage of the gravity flow to get the material there for as minimal a cost as possible. So once this material gets to a wastewater treatment plant, it will go through different physical, chemical, biological treatment processes. First, the material will go through think of it as a progression of very coarse treatment to very fine treatment. And what you'll have is what they call bar screens, which in effect are what you think of bars in a jail.
Yeah.
But they're much tighter together, maybe 5/8 of an inch, 3/4 of an inch, it just depends on the municipality. And the wastewater will hit that, and we'll have these rakes that go up the bars, and they'll remove the large solid material, be it
Don't go
large.
into detail.
Okay. It's a family show, so I'll try to keep it nice. And so that material will typically get raked up, put on a conveyor belt, put into some type of truck bed container to be hauled to a landfill and disposed of accordingly. Perhaps HPR would be a place for that, I don't know. But then the material next would go through a process to try to settle out the real heavy stuff. In your collection system, you probably get a lot of sand, coffee grounds, things like that. So the water will go through this thing called like a grit chamber, and that will shake out the very heavy stuff, because the municipalities don't want that heavy stuff to get into the equipment beyond there, like the clarifiers, the digesters, and things like that, because it will really cause problems in those tanks. And that material will also go to the landfill. So what you have left is it's a water solids mixture of the lighter solids and the wastewater that hasn't been treated. That will go through typically, and a lot of plants are different, but this is a typical plant, primary treatment, which is more of a physical treatment where you have settling, just gravity settling. It's a big wide spot in the pipe. It's a tank, maybe million-gallon tank. I don't know what it is here at Sand Island. And so material will sink to the bottom, other material will float to the top. They'll scrape the bottom, skim the top, and take that material and typically put it into a digester. Other plants, and what Sand Island has recently done with EPA's more stringent regulation, has done some chemical treatment in that tank to aid in the settling of the material so that the water can be cleaner. And that's called advanced primary treatment, where they add a chemical, a flock. In this case, it's called ferric chloride, and that aids in the settling of the material to make the water easier to treat beyond that point, or in this case, because Sand Island does not have secondary treatment, more suitable for discharge to the ocean. So now you have water that's been treated, and there's still more treatment to the water, but that's not relevant to what we do. That's what the city and county does. The solids will be then transferred to Synagro, in this case, to digest the material. So what you have is the residuals from the treatment process to date, and it's high in volatile solids, high in carbon, high in matter that can go through a process to reduce it more, to make it more stable so you have less trucks going out. And so what you have in this big tank, and I'd equate it to your stomach. You know how you digest food? That tank is like a stomach, in effect, for an analogy, where you have different types of bacteria in there in what they call an anaerobic condition without oxygen, where acidophilic bacteria, methanogenic bacteria work in concert to digest the solid material to make it more stable so there's less of it. And so what you get is a methane gas that's created, and you'll have a more stable product. And that's why I like to call us a resource recovery center, because we're not just recovering the nutrient value of that material, we're also recovering the energy value of that material with the methane gas. And so you capture the methane and you combust that methane. You can do that to make energy, or you can use it to make heat. And we use that for the heat for what we do as the dryer, because when that sludge in the tank goes through 15 days of treatment at 95 degrees Fahrenheit, EPA has dictated that now is a stable product, and they call that Class B biosolids. So we have that, but we want to make it, I think the city and county did the right thing by deciding to make a Class A product. And we'll take that and we will do what you call dewatering, where you put this material, it's still pretty aqueous, I think maybe 5-8% solids at that time when it's going to the centrifuge?
Actually, when it comes out of the digester, it's about down to 2-3.
Oh, still 2-3,
Yeah.
okay. And we don't have any gravity belt filters or anything?
No.
So you'll get this liquid, it's still in effect a liquid, and you don't want to truck off liquid or dry liquid. So you'll have a mechanical dewatering. You can do that various ways. Some treatment plants use a belt filter press where you're too young to remember this, but when you used to roll clothes through a rolling device to dry it.
I'm not too young.
And that's where you'd squeeze the water out of the
Yes.
clothes. The same thing with the belt filter press. You'll put the biosolids on these belts, and you'll have rollers that will squeeze the water out.
Mm-hmm.
Sand Island is much more sophisticated. We're prudent enough to invest in centrifuges. And that's just a high-speed spin,
Yeah.
and the water just spins out.
Which is what the modern dryers, washers do.
Thank you. And so now you have a solid product, and it's amazing. You'd think it's dry, but it's still roughly 75% water at that time.
Mm-hmm.
I think we're maybe 25% solids coming out of the centrifuge, maybe 28?
25.
25.
Yep.
And so now what you do is, that's still Class B. In order to get to the next step to Class A, you have to go through the process to further reduce the pathogens. And there's several ways to do it, but in this case, we're using time and temperature through a heat drying process to dry the material to greater than 90% solids, and I think we're at 92 typically.
Greater than that, yes.
Okay, and so that's through what they call a rotary drum dryer in this case, where it's a triple pass and the material's going through these cavities within a dryer as a flame is thrown through it, from the digester gas in this case,
Yes.
to dry out the material. So you have a self-contained system with the energy created by the sludge to dry the sludge. So it's a pretty nifty system they put together there. And so now then you have these pellets and it's a very sophisticated thing that would be very difficult to explain, how we make a very perfect spherical pellet that has a certain millimeter size and hardness to make it ideal for the fertilizer market. And those are shipped off through our local on-island representative that processes and sells the product.
Now, if a farmer wanted to get that product, how would he go about doing that?
Well, you have to contact the distributor that is partnered with us here, Neo Nursery.
Oh, I see. And so Neo Nursery sells only to farms?
At the moment, that's correct. Yeah.
Yeah, he is. I mean, he does that. That's pretty much the bulk of where he's selling it. He's working on market development, again with a very small percentage right now, which is we're trying to work on expanding it to create a higher value product through soil blending and through fertilizer manufacturing and custom blends of this product to supplement, like what Michael said, the NPK value, which is nitrogen, potassium, phosphorus, or phosphorus, potassium. I always get the P and K mixed up.
Right.
And in order to custom blend the material to fit the needs of different markets.
And you said that that NPK value was 420?
420, yes.
And so that would be 4% nitrogen?
Nitrogen, it's a ratio of nitrogen, phosphorus, and potassium.
But what does the number represent? Is it percent or can you tell me? Like when we buy fertilizer, we buy 10, 20, 20, and I'm not even sure what that means.
No,
So is that the
Sorry.
same thing?
I think it's percent, but we'll get back to you on that. And you can supplement it on your next show.
Okay.
Yeah.
Well, I always make it a point to, when I have food waste, I grind it up. And I say that I'm recycling it. Is that correct? Now you said that, I didn't realize that there was some lifting off of the solids before it went into your plant.
Well, before it comes to our plant. It's
Right.
not before it gets to the city and county's plant.
Yes, I understand.
Yeah.
So that before it goes into your digestive system,
Right.
that part goes into H-Power, you thought?
I don't know. I don't know what the city and county does with the material that comes off their bar screen or grit chamber. Typically, what municipalities will do is they will send that to a landfill, and they very well may do that. That would be my assumption, but I don't have the answer to that.
And so what percentage of solids is that?
I think it's very minimal. I don't have that data for this plant because it depends a lot on the size of the bar also, and that again is outside our bailiwick per se.
Yes, because you get only what they.
Yeah.
They provide, yeah.
Yes. So, but I just never knew that. I thought all of the solids went into
Well,
Central.
if you're grinding it, I would assume through a garbage disposal when you.
Yes.
Yeah, and that would typically easily make it through a bar screen. So that material would bypass, depending on the density, if it settles out in a grit chamber, it would bypass through a bar screen and get into the treatment system, end up typically in the digester to create both the pellet and the digester gas. So it would be a beneficial use of it. Other beneficial use that people do at home is they even do some home composting of that
Oh,
material.
yes, I do that too, but
Yeah.
what I can't compost, I put into the garbage disposer if it's
Absolutely.
possible, you see.
I think that's a better use personally. Speaking on behalf of myself.
However, it doesn't come to me directly. My compost goes into my garden directly, you
Excellent.
see. Well, and now let's talk about what happens with that gas. You said that in the digester, which, let's see, you called it I forget what you called it, an egg?
Yeah, there's different types of digesters. Maybe I should talk about that. Different shapes and sizes. And what the city and county has employed is what they call a egg-shaped digester. And it might be a good time to perhaps take a picture, take a peek at the picture over there that I know we have available.
All right.
Yeah, and that's what we're talking about. When we talk about an egg-shaped digester, it's that spherical ball in the dead center. And that tank, what you see there, has a capacity of about 2.3 million gallons. It can hold that much material. And that's where the heat can be used is used, candidly, to keep that vessel at above 95 degrees Fahrenheit. You have to keep it above 95. EPA rules mandate that the material have what they call a mean cell residency time, or the material has to be in that tank for at least 15 days at least 95 degrees Fahrenheit, and it cannot go below that, or else you're not achieving what they consider Class B status. One of the safety valves here at Sand Island, we do have the dryer, so you're not necessarily beholden to that, but that's good industry practice to keep it at that. And so this egg is where that material goes into and where the digestion happens. You may see at different plants where they don't have an egg. What they'll have is a cylindrical tank, just with a lid on it, and typically with a little bit of a concave on the bottom where some of the solids that aren't part of the biosolids settle out, and that occasionally has to be cleaned. What the nice thing is about this type of digester is it has more of a self-cleaning type of function, where with the sides not coming down at an angle and keeping the mix going, you don't get as much buildup of material. So that helps with the cleaning cycles.
Right. So what we saw was spherical.
Yes.
But what we didn't see is the part that slopes, so that
Right.
it's more like an egg.
Yeah, and what this looks like in the picture again is like an egg
Could
on.
we put the picture on again, please?
And you can see that white ring when he moves over to that.
Could we put the picture on again, please?
Yeah,
There.
and you see that white band under there?
Mm-hmm.
Think of that as just something that you're setting a ball on. It's like a
Yeah.
T almost.
Mm-hmm.
And you just project the sides of that spear continuing to curve in underneath that white area. And so it's just like a ball up on a T. Think of a golf ball on a tee. I think that would probably be a good analogy there. And so for that reason, you don't have the straight down walls and the corners at the bottom where material kind of hangs up in here, and so you have a much better engineered type of vessel for the digestion process.
So it has to be a continuous process, right?
Yes.
And so how can you tell that something has been in there 15 days?
It's a mathematical formula that EPA has put out with the way that the egg is configured, the amount of time, making sure that the valves and the pipes within that don't have the potential to short circuit such retention times. So it's engineered as such and approved by EPA.
Now, we're in the process of getting a second digester,
That's
correct?
correct, yes.
And the reason that we need that is not only the growth in population, but the more stringent requirements of the treatment, so that we have exceeded the capacity of the one digester sooner than we thought. Can you explain some more of that?
A little bit of that. I'm not sure of the history of the need for the second digester, but we are at capacity now, and with the prospective population increase and growth of Honolulu, as rightly so, it's a beautiful city. The need is known to need a second digester.
And I can touch on the history a little bit, because when it was first designed, it was designed adequately for what was projected to be produced at the time when the bids came out, when the design came out. The city and county did not have the mandate yet from EPA to do additional treatment. And so when that occurred after the first egg was designed and built, and it wasn't foreseeable at the time of the contract, it caused more solids to be produced, because EPA wanted the city and county to produce the cleaner water for discharge into the ocean. And the way to do that with the existing equipment is to use a process, what you call advanced primary treatment. And so in that tank, the first tank where I told you things settled and floated and they scraped it off and put it in the digester, we were doing fine. It was under capacity, you know, and everything was going along smoothly. With the additional regulation, the city and county had to do some chemical treatment just beyond what is basically the physical settling or floating. And that advanced primary treatment involves the addition of a flocculant, a chemical. In this case, I think the city and county uses ferric chloride. And when you do that, it increases the amount of solids you take out of the water, with the goal being clean the water and treat the sludge. And that, the difference between what was being produced without that additional treatment versus what was being produced after that treatment is what caused the excess capacity. So I don't think it was foreseeable at the time the city and county you know, went through the
And
process.
so at this moment, without the second digester, are you at full capacity, or do you still have excess capacity?
No, I'm at full capacity.
Yes. So that, what is happening with what you cannot treat?
There's, you know, and you know, correct me if I'm wrong, but there is, that's what capacity is. There is contingency capacity, or you're able to treat more within the vessel. It's just not the ideal design capacity. There is room within that to add material. You may not go, I think what's the average retention time right now?
We're at 21 days right now.
Yeah, and so
When the
we're,
requirement is 15, yeah.
yeah.
So does that mean that you could put it through faster and you would have more capacity?
Well, they have tanks, holding tanks, the clarifiers, the waste storage tanks. So we have storage tanks to allow for that buffer.
Yeah, but that's just one function. I mean, there's just the amount of residency time you have in the facility. There's also the physical conditions within the tank with the volatile solids, with the gas production and all that. And so there's a delicate balance throughout the treatment of the system that doesn't have that 15 or 20 day dictating what is the capacity. So there is other
So is
factors.
21 days good or bad?
It's more than adequate on the time for the purpose of compliance with the regulation. It would be very nice to have more time in a digester to create a more stable product. And that's what we're having issues with right now, is pushing it through, making a fine product, but you know, it's very tight with the ability to really juggle. And I think Michael's doing a great job to keep it flowing safely for the citizens here.
Okay, well, we're out of time, but thank you very much. Lane Baroldi of Synagro, who has come to visit us, and from Los Angeles, and Michael Marrero, who is the plant manager here in Sand Island. I'm Pearl Johnson with the League of Women Voters. Thank you for watching.